So I'd like to welcome everyone to the final talk in the Spectrum Scale digital events for 2020. This talk is event-driven data management and security using Spectrum Scale. Can I have the next slide, please? So we have four speakers today. We have Jürgen Hannepel, John Olsen, Jake Tick, and Louis Terran. So John Olsen is a senior software engineer with a Spectrum Scale security architect. He's been at IBM for 21 years and has worked on Spectrum Scale since 2004. Jake is a development manager for Spectrum Scale. He's been at IBM nearly 6 years, and he's been on the Spectrum Scale test team and FBT test team. He's now moved into management to help lead file audit logging and watch folder team. And Louis has been at IBM for 4 years, and he's a lead developer for the clustered watch folder and file audit logging. Louis started his work with system test on Spectrum Scale, then moved into development role afterwards. Louis now enters development for the file audit logging and cluster watch components. Can I have the next slide, please? So there's a standard IBM disclaimer for the slides. So Jürgen is from DESY. This is a customer talk. He's going to talk a little bit about how they're using policy engine and data management. Jürgen, would you like to introduce yourself? Because I didn't have a bio for yourself either.
Yeah, so my background comes from particle physics. And since 2017, I'm at the DESY IT department, where I work mostly on the GPFS installations, which we have for two different use cases, basically. And I'm now going to talk about how we use the policy engine in our data management. Yeah, so DESY and the European XFEL are closely related large research institutes in Hamburg. DESY, since 1959, works with accelerator science, particle physics, photon science, which is science we got using X-ray photons, which are not created with the normal X-ray tubes you get at the doctors, but with large accelerators, so you get very high brightness and good quality of these X-rays, and astroparticle data. It has two locations, one big one in Hamburg and a smaller one in Zeuthen near Berlin, with about 2,300 employees and about 3,000 guest scientists per year. The European XFEL, which was founded in 2009 and started operation in 2017, does only photon science. It's located in Schenefeld, which is near to Hamburg. In fact, it's connected with a 3.5 kilometer long accelerator, which starts at the DESY campus and brings the electrons which create the X-rays to the XFEL campus in Schenefeld. Next slide, please. So for the setup of our data operation, this looks basically similar for the Petra 3 accelerator and the European XFEL. Data are generated at experiments, which can easily reach something like 400 files per second and 5 gigabytes per second, and can produce up to a petabyte per week, or in unlucky cases for the data management, even a petabyte in 1 weekend. This data go to an ingest file system, which has an SSD tier in GPFS of typically about 200 terabyte in size, and a spinning disk tier, which adds some more capacity to this ingest file system, which has 200 terabyte in the Petra case and 1.5 petabyte in the XFEL case typically. At XFEL, we in fact have 3 such ingest file systems in different instances. Data are then moved to a so-called core file system or offline file system, which is 6 petabyte in the DESY case and 12 petabyte in the XFEL case. then the data are moved to an archive system, which is DCache, which is a development by DESY and some other high energy labs. And from there, data are stored into an archive system, which is a tape library. Data are accessed at the time they are taken on an online compute cluster, which uses this ingest file system to access the data. And also during data taking, and especially later for analysis with a larger compute cluster, which presently has about 650 nodes, but which is steadily growing. And this accesses the data in this core file system. All of these parts, except the experiment and the DCache, are connected via InfiniBand. If we go to the next slide, in such a system, we have a lot of data management tasks. We have a lot of data sets, and we organize the data sets in GPFS file sets, so that basically everything which belongs to one experiment goes into one file set, so it can be managed quite easily. Typical tasks which we have in our environment is migrating data from the SSD pool to the disk pool in the ingest file system, or copy data from the ingest to the core file system, copy data from the core to the archive. We generate some file lists for a user portal so that users can see which files they have without doing an LS. This is necessary because some of the data are accessed from outside, and people don't really have access to the file system directly, just via this user portal. And also, we need to detect unused data when we want to clean up our space. On the next slide, we see the typical data lifecycle. So data are created, typically in the ingest file system. Then they are transferred to the core file system, which is done with the assistance of some policy engine. The copy to the archive is also policy assisted. Data are, after an experiment is done, removed from the ingest file system, basically by just deleting the file set. And when data are no longer accessed for some time, typically a year or so, which we find out also via a policy run, we do a so-called data copy to archive, which records all the changes which have occurred since the first archival of the data, again to the archive, and then we remove the data from the core file system to free up the space. On the next slide, we see one policy rule set, which is used in the example of migrating data from the SSD pool to the disk pool. This is basically the standard example from the GPFS documentation. So we have an initial placement rule, which tells the system to put the new data into the SSD pool, which is called cache. If that's full, we put it to the spinning disk pool, which is called data, and another pool migration rule, which doesn't really migrate the data, but rather triggers a callback, which then executes another rule, which is shown in the next slide, which looks up the data where the access time, where it looks up data which were not accessed in the last 2 minutes, and migrates them then to from the cache pool to the other data pool, and does this with the oldest files first. And this is always called when the low disk space event comes, which is triggered by this previous rule on the previous slide, which sets basically the limit. So this is basically standard policy engine rules as defined in the, or as shown as example in the documentation. On the next slide, we have a somewhat more complicated rule. This is used for copying data from the ingest file system to the core file system. This is done via an external list because we can't use the internal migration because we migrate between two different file systems. The rule just checks if the files are old enough, in this case not accessed for 8 minutes, are in the correct file sets and were not yet migrated. This is done by this check on the extended attribute for migrated and have and if they were unchanged since last migration, which we check via the M time and file size, they are also not again checked. And this rule then triggers an external program which does the copy and sets the extended attributes so that we can see if the files were migrated or not. This is doing it this way makes it very efficient because we don't have to go through the files with find or ls and check up the metadata ourselves. This is all done by the policy engine. On the next slide, we can see what we achieve with this. This is the number of files transferred per second when such a policy run is executed. And there is a lot of data to transfer. And we can see that we easily go up to 400 files per second with 2.5 megabyte files, which are transferred in 1 second. Of course, we always get many files first. Some files take a little bit longer, which is why we get this tails. We call this cron job every few minutes. So you see this bursty nature. On the next slide, we have a short summary on this policy-driven copy rules. It works very reliable. It always does what it should. It makes efficient choice of the data using the metadata like the extended attributes. And that's very nice, very efficient and fast. But it's driven by a cron job. This means it creates some bursty load on the system. Every time the cron job fires, you get a burst of activity, and you get a rather long delay between the file is closed in the ingest file system and the copy is done because you have to wait for the next cron job to run. To make this better, we have an event-triggered mechanism described on the next slide. This overcomes this cron job-based latency issue. We can't use AFM, which in principle would solve this also, because we have to transfer ownership between the ingest file system to a different ownership in the core file system. AFM would keep the owner, so that won't work there. What we do is we trigger a copy from an iNotify event. Instead of iNotify, we could, of course, also use watch folder, but the solution was developed and put into production before watch folder was available. So at present, we keep the old implementation because it's working very well. This is very fast. Usually, it takes only a few tenths of milliseconds from the close of a file to the finished copy. Of course, if the file is very large, it takes longer. But this goes very fast. Sometimes users have very strange ideas of what to do with their files. For example, open it, write something, close it, open it again, write something additional, close it again, and do this 100 times. And because every close triggers a copy, we get into problems there, because while I do the copy, the next change at the file is done. I see it has changed. I have to do the copy again, and so on. So this may cause this event-triggered copy sometimes to fail or take very long. So I still need the policy-driven job as a fallback if I want to have really copied all files from the ingest file system to the core file system. And on the next slide, we have a small summary. We automate everything that can be automized. The policy engine helps us a lot in this because it makes it simple and fast, much faster than it can be done with scripts that use ordinary Linux tools. But for really fast actions, we need event-triggered methods, which can be done either with a notify, which is a bit difficult, of course, if you have many nodes which modify files, or with the watch folder. Watch folder we have tried, but not yet in production. Thank you.
All right. Thank you. I'm John Olson, and here's what we're going to talk about from the IBM folks. I'm going to talk about the basics of file audit logging and cluster watch folder, as well as an overview of the architecture in 5.1.0 and some basics on how to use them. Then I'll pass it over to Jake, who's going to go over some use cases in file audit logging and clustered watch folder. And then finally, we'll move on to Luis, who will talk about a new event, access denied, and also why you should upgrade to 5.1.0, how to monitor file audit logging and clustered watch folder, and also information on upcoming user group presentations we're planning on having in the first quarter next year. Next slide, please. So some folks aren't real familiar with file audit logging and clustered watch folder, so we'll give a brief overview of them. Then you'll see how they're actually used in some use cases that are going to be presented, as well as some best practices. First, each of these is considered a tool that's used for a different purpose. File audit logging should be considered a tool that's used to audit file system operations over a distributed file system. Information is written to a log file, hence the logging in file audit logging. One of the most important things about file audit logging is that it logs file system operations at the file system level. This means that it is protocol agnostic, and whether or not you're performing POSIX operations or you're coming in over NFS or SMB, when the operation reaches the file system, we can generate an event. And this is one of the things that makes file audit logging a very powerful tool. We log what standard users would consider file system operations. Things like opening a file, closing a file, removing a file, etc. In all, we log 10 different event types. We take the information known at the time the event was created and put it into a JSON object that gets written to a retention-protected file set. Specifically, it's either IAM mode non-compliant or compliant, with the difference being that on non-compliant, the root user is allowed to change the expiration date of the audit files in order for them to be allowed to be removed to free up space if needed. The level of granularity for file audit logging is that it's the file system that is audited or not audited. But you'll see some more details later on about how you can only audit a subset of file sets within the file system or audit the whole file system and skip a subset of file sets. You'll see those in some of the use cases Jake's going to be presenting. Clustered watch folder, on the other hand, is a little bit like iNotify in Linux, except it is much more powerful because you can watch file operations over a distributed file system instead of just on a node-by-node basis like iNotify. Again, one of the most powerful and important things about Clustered Watch Folder is that, like file audit logging, it captures events at the file system level, and it's also protocol agnostic. Like file audit logging, we can generate an event no matter how you get to the file system layer. This also makes Clustered Watch Folder a very powerful tool. Similar to file audit logging, file system-based events are generated, except they are for iNotify style events. These are things like in-close write, which means that a file that was open for writing was closed, or in create, which means a file or folder was created. In all, we generate 12 different iNotify-like events. We take the information known at the time the event was created and store it in a JSON formatted object. Unlike file audit logging, we don't write these JSON records to a file set in Spectrum scale. Instead, the JSON records are streamed to an external Kafka sink. This is the Kafka cluster you set up, and you receive these JSON objects, you consume them, and then you perform some operation based on what you see in the object. So this is a tool used to take action based on file system events that occur in the subsequent JSON records that are read from your Kafka queue. Where Clustered Watch Folder also differs from file audit logging is that you can have multiple watches on a single file system or even on a file set. And you'll see more about this when we go over some of the use cases. Next slide, please. So where should I use file audit logging? Well, when you need to audit file system accesses, when you need to know who did what file system operation, at what time, what was their user ID, and a whole lot of other information. Basically, when you need to record the file system accesses, use file audit logging. I said in the previous slide to think of file audit logging as a tool. This tool is used to track file system accesses for compliance reasons. This tool is used for security compliance. We get the events generated when the file system accesses occur, and we store the who, the what, the when, etc., and store these records of information in a tamper-resistant file set and allow you to set the retention times or expiration dates of the audit logs themselves within the file set. By default, the file set is created in IAM mode non-compliant, which, as I said, means the root user can change the expiration dates of the audit logs. You can also choose to enable file audit logging in compliant mode, which means not even root can change the expiration dates. Next slide, please. A little bit more about Clustered Watch Folder. When I want to take an action when there are changes in the file system, but policy scans are too slow for what I want to do, that's when I want to use Clustered Watch Folder. I need to be notified as soon as the access occurs so that I can take action. What I need is the ability to watch part or all of the file system and take actions based on what happens. So the solution to this problem is to use Clustered Watch Folder. And as I said previously, Clustered Watch Folder is also a tool. This tool helps me take action in response to file system accesses. Instead of waiting for a file system scan to complete to later learn what happened, when the file system access occurs, events are generated and information is stored in the JSON records that are streamed to the Kafka sink. While I'm monitoring the Kafka queue that is receiving these records, I can take whatever action I need to take based on information in these records. And as previously mentioned, this is a tool that fits the need of what DESY needs to accomplish and can help transfer files throughout the life cycle of their files. Next slide, please. Here is an overview of the architecture for file audit logging and clustered watch folder. Previous to the 5.1.0 release of Spectrum Scale, we would write the JSON records to an internal Kafka queue within Scale, and then we would read those records and either write them to the audit file set, if they were audit records, or to the external Kafka queue, if they were clustered watch folder records. What you see here is the new architecture. There is no internal Kafka queue. We have producers within the daemons running on the cluster nodes, and for file audit logging, we write the JSON formatted records directly to the audit file set. There's no middleman anymore. For clustered watch folder, we have producers again within the daemon that write the JSON formatted records directly to the external Kafka queue. Again, we've removed the middleman. In addition, clusters that have the file system remotely mounted that is either being audited or watched will have a producer in that daemon that will write the record directly to the audit file set for file audit logging, or the producer of the daemon will write directly to the external Kafka sink in the case of clustered watch folder. All of this is orchestrated by tying the file system level of 5.1.0 to the ability to use the new architecture. There are a lot more gory details that you can read about in the Knowledge Center. I think we have some really good documentation in there. And also, you'll be seeing some more details in the use cases and monitoring that will be coming up in this presentation. Next slide, please. So how do I use these? Well, both file audit logging and clustered watch folder can be controlled either through the CLI or the GUI. What I'm showing here is just some basics of how to do it through the CLI. For file audit logging, it's just as simple as using the enum audit command, stating the device you want to audit, and then saying that you want to enable an audit. For clustered watch folder, there's a little bit more you have to specify because it's a little bit more involved because you're streaming to an external Kafka sink. You have to specifically provide the broker address or addresses and the topic that you want to write to. It's still pretty simple, and you can use the enum watch command. Given the device that you want to have the watch enabled upon, state that we're going to use the Kafka sink. We have that required because in the future we may have some other things where you can send records. In addition, you have to specify the broker or brokers in the topic. As you can see, it's pretty simple to enable both file audit logging and clustered watch folder. But even though they're simple to enable, they provide powerful tools that can be used in different situations. And to see more about how these tools can be used, I'm going to pass it on to Jake, who's going to go over some use cases.
Yep, thanks, John. So I want to start first with a simple use case, and probably one of the best use cases for clustered watch folder, and that's I want to be notified when a file has been written to so I can take action on it. In more detail, this kind of goes back to the DESY use case that Jürgen explained before. But when files are written to and closed on, let's say, a file set, I want to be notified for that action, and I want to be able to do something with that file, whether that's move to a different file set, take action upon it, delete it, change an attribute, whatever. That's what I want to be notified about. So the solution here would be clustered watch folder. In short, you could set up a clustered watch on, let's say, your Data 1 file system, and you can enable it to just watch for file set tier 1 in this example. Here we'll have file set tier 1 for the sake of this example, map to a pool of storage that's say SSDs or NVMEs. So it's your fastest tier storage. What you want to do is be able to be notified when an event hits this file set and move it off to a different file set as soon as it's saved. So like I said, you would enable a watch on that file set, and then you could watch for just the in-close write event here. By default, when you enable a watch, it will watch for all events, but you can specify an exact event you want to watch for. Like John stated before, you can pass the events or stream the events over to your Kafka Sync brokers and push to a specific topic. Now let's take a little deeper look at the JSON here. As John mentioned, there's a ton of good metadata that we pull from the event at that time that it occurs. And in the case for DESY, we can see here that we got an in-close write event, and it happened on fresh file 1, which occurred on the tier 1 file set. We actually collect the pool. We can see the pool name is gold. The file size is 34,000 bytes. The process ID of what generated or what touched that file. And we can actually use the metadata we capture at this time for things like A time, which is the last time that file was accessed. So we do collect a lot of data here to be able to create a custom consumer on the Kafka end to take action on those files. Note that the end user does have to create that consumer on their Kafka Sync to take action. That's not something that watch folder does inherently. Another use case for clustered watch would be cataloging and visualizing data better. So let's say you're an organization that has obviously many users and many groups using the file system, and you want to be able to visualize what group or what user is accessing files that are of the biggest size. You want to be able to see who's using up the most space. In this example, you could, again, start a clustered watch, but this time on the entire file system. So the entire file system being FS1, as you can see here. We enabled it, again, on the in-close write event to see who is creating or accessing and saving files. And we're sending it to an external sync topic called visualize. Now, from there, after Spectrum Scale and Clustered Watch Folder has sent that JSON record over, you could, for example, use the ELK stack here. So you could use the Logstash Kafka plugin to feed the events that Spectrum Scale and Clustered Watch Folder sent, and you could get them into Elasticsearch. Based on those previous metadata records that we had showed before, you could pull things such as user ID, group ID, file size, storage pool, access time, etc. And using those JSON objects, you can create custom dashboards inside of the, let's say for this example, Elasticsearch, and you can visualize that on a user subset or even a group subset to see the file size, which correlates to what user or what group. So next I'll move into a couple of use cases for file audit logging. In our initial implementation of file audit logging, it was an all or nothing. You enable file audit logging on the entire file system, and that's that. So things have changed recently. We got customer feedback that maybe, hey, I don't want to audit my entire file system. I only have a few file sets that I want to audit. So let's take an aerospace company, for example. They have hundreds of file sets, but only 2 they want to audit because they contain confidential data. For security and compliance reasons in their organization, accesses or records of what happened on those 2 confidential data file sets need to be kept for 120 days. So without having to watch all of the other accesses on the file system that they don't really care about, they can enable a file set watch on just the 2 file sets, or I mean a file set audit on just the 2 file sets that they care about. So as you can see here, the user can pass the audit command. They can enable it on the file system FS1. And by passing in this file sets flag here, you pass in a comma separated list of file sets. Now those file sets can be dependent or independent, it doesn't matter. And you can pass in, like I said, a comma separated list. Now, in this use case, like I said, the confidential data records must be kept for 120 days. So you can, again, pass in the retention flag and set it to the amount of days you need. Now, by default, the audit command will, like John said, save a retention policy or the retention date to a full year, 365 days. So kind of on the contrary here, another customers did say they would want this as well, but they want to audit their entire file system, but there are a subset of file sets that they don't care about. Maybe there's processes on them that are causing a lot of traffic or a lot of accesses, and they don't need to be audited. So let's look at this in a little better example. So say you have a banking company or a financial institution. They have a big file system and multiple files, hundreds of file sets on it. All of the banking records and financial data need to be audited for, again, security and compliance purposes, but they have a data mining process that is out there, and it is combing through the data and doing whatever it may be doing, and generating a lot of file accesses there. However, that data mining process is set up to write its temp data and process data to two file sets. Those can be seen here as the data mine process 1 and the data mine temp file set. Now, like I said, the financial institution or the bank, whatever, they don't care about what happens on those two file sets, but they do care about everything that else happens on the file system. So what they can do is set up a audit on the FS1 file system, and they can use the -- skip file sets flag to, again, pass in a comma separated list of independent or dependent file sets that they do not want to be audited at that time. And here I'll pass it over to Luis to talk a little bit more about one of the final use cases or another use case for file audit logging, and that would be with the new access denied event. So, Luis?
Awesome. Thank you, Jake. So today I want to walk through a new use case that we now support in Spectrum Scale 5.10. This use case is now made possible thanks to the new event we introduced called access denied. For example, let's say I need to protect my organization's crown jewels. I want to know if users are trying to access this very sensitive data when they don't have the necessary permissions to do so. Well, we can enable file audit logging with the access denied event. So let's dig into what kind of information we can extract from the audit records. Let's say the organization's research team has been working really hard on patenting an invention, and the disclosure is being worked on by multiple people on the research team, and they share a file named invention_disclosure1. This file has really sensitive data, and you want to keep track of any irregularities that might be happening on the file, like users trying to access that file when they shouldn't. So using, for example, a SIEM solution, IBM QRadar as an example, you can set rules to alert you whenever a user attempts to access the file. They are not allowed to access if you are feeding these audit records to that SIEM solution. In this scenario, you receive an alert that user 1001 has attempted to write or delete the file. You also have information on there like the event time, and also the permissions that were set on the file and the process ID of whoever tried to access that file. Again, this is a very simple scenario, but with a great amount of event metadata that you have, you can create very detailed and custom rules or queries to keep track of this file system activity again, given that you're feeding all these audit records to a SIEM solution, maybe it's an in-house SIEM solution, and I already mentioned like IBM Q Radar or something like that. All right, Jake, can you go to the next slide? All right, so in the previous slide, we talked about a new feature that we added in 5.10, but that's not all we added. We also took a re-engineering step and tried to really simplify our whole architecture for both file audit logging and watch folder. So John already touched a bit on the architecture for 5.10. This diagram right here represents what we had previous to 5.10. As you can see here, we have a spectrum scale cluster with a few nodes. And what would happen prior to 5.10 is that we would push the records, the JSON objects, to the brokers in the message queue outlined here in the diagram. The message queue required us to have local disk space on broker nodes. This was needed to be able to persist messages in this, if you want to call it, intermediary step. So because each node sent messages to the message queue, we also needed a user space processes in this diagram, the conduits, to forward messages from our internal message queue to wherever the ultimate target might be. Kafka sync in watch folder scenario and the audit log for file audit logging. So what has changed? These added components, they were just requiring extra resources. So in 5.10, we got rid of the message queue, we got rid of the conduits, and now all these nodes directly communicate to the external sync. And for audit log, it just becomes the audit log. So yeah, this really simplified everything, and it makes it much easier for us and whoever's using the feature to manage, and it just makes it more efficient. So to quickly summarize what we just went over, I want to explain why we should upgrade, why you should upgrade. So what does the removal of the message queue and user space processes really mean? With the removal of the message queue, we've now eliminated the requirement to have the broker and Zookeeper nodes. So there will also no longer be Java processes running on the nodes that consume extra resources. You will also no longer require the local disk space that was needed. I also want to go over some points regarding stretch clusters and remote mounted file systems. Some customers have asked about running file audit logging on stretch clusters and remotely mounted file systems before. With the message queue, running on a stretch cluster is not recommended due to the increased latency that the communication between the brokers and Zookeepers had that was causing issues. So in 5.10, now you can actually run in a stretch cluster. As far as remotely mounted file systems, we've been supporting that since the 5.02 release. The only caveat is that you need to enable file audit logging and clustered watch folder from the owning cluster, but this is still available in 5.10. And to finish off with the improvements, with all the management that needed to be done before, the commands would take quite a bit of time to run. With this new simplified architecture, the commands are a lot faster. Simple is better. And next slide, please. All right, so moving on to monitoring and keeping track of the state of your audits and watches. You can use mmdiag -- event producer to look at statistics about the audit and watches that you have running. You can see statistics like per event, how many events have been sent versus delivered. Sent in this context means that an event was generated from GPFS. Delivered meaning that we know that it was persisted on the Kafka sync or that it was written to the audit log. Both file audit logging and watch folder are integrated with Health, so you can keep track of status that way as well. And the GUI also displays audit and clustered watch health states. So you can also take a look at the GUI to make sure everything is running fine. All right, thank you. So what is still to come? File audit logging and clustered watch folder can really be utilized to their full potential when integrated with SIEM solutions. Based on talks with customers we've had, there are a couple of SIEM solutions that we have heard about, IBM QRadar and Splunk. So based on that, we want to have a couple of user talks of how you can integrate our features with IBM QRadar and Splunk. For file audit logging and QRadar integration, we are planning a user group presentation in Q1. There is already a QRadar and file audit logging integration redbook. We are planning on expanding on that redbook with the new access denied event and possible use cases regarding the access denied event. A link to the existing redbook is provided in the links and resources slide of the presentation, which should be made available. We will also be presenting on clustered watch folder integration with Splunk in that same talk. But now to wrap it all up, please let us know if you have any questions or any requests that you would like to hear more about regarding file audit logging and clustered watch folder. We're open for feedback, and thank you. So I'll hand it over, I think, to Ted, who will walk us through the last few slides of the presentation.
Before Ted jumps in, I just wanted to point out that the question that was originally asked by Michael Henneke and a couple of others in the chat, but nobody actually posted it in the Q&A, so I couldn't answer it in the Q&A. I asked Felipe, and he actually provided the information. I posted it back in the chat that says, yes, automatic space reclaim or the trim support is there in 5.1, and I posted some information. You can run an change config command to set a threshold, and that will kick off those reclaims in the background when you hit those thresholds. Thanks.
Thanks, PC.
I think there are some unanswered questions on the chat and on the Q&A.
John or Luis, can you guys read those slides? I'm in full screen mode, so I can't see the Q&A from this view.
I think most of them have been answered now.
Oh, okay.
Yeah, okay, yeah, they have been answered, fine.
There's one, scaling recommendations for Kafka sync servers, memory CPU based on IBM internal testing DESY file system. That's a good question. There's a lot of information out in the literature about sizing Kafka. I would probably look to that. I know that when we had the internal Kafka queue, the message, what we're calling the message queue, when we were using that, we would recommend that the sync Kafka be about the same size. And so we had internally, minimum of 3, recommended 5 brokers for a message queue. That's, as a minimum, I would say something like that. But there's a lot of good information out there on sizing Kafka based on your workload. Does that answer your question?
So Mark can't speak, but I think,
sorry.
Yeah, the other thing, John, that we should probably post is that I remember a few years ago, we had done an internal test that says if you want to run up to like 10,000, 50,000, 100,000 kind of messages, we were able to keep up with that with 3 servers with a local SSD and some, I forget what the network was, etc. I think that would be also a little bit useful to provide, but yes, Kafka in general has a lot of good recommendations, and basically we just piggyback on that.
think there's one more question that just came on the Q&A if we want to read it here. So can watch folders be based on a whole file system to pre-migrate all the new file sets added to the ESS SSD tier or to a COS tier?
You can have a watch folder based on the whole file system. You can even have multiple watches on the same file system. So it's very, very flexible that way. And what you do with it will depend on what you have in your consumer on at your Kafka sync.
So if I could add to that, the action you take in response to the event is completely up to you. If you want to move it to, if your action is to move it to a COS tier, to a tape tier, that's up to you. You can definitely do that.
Okay. Is there any other questions?
So there is one question which I don't think is a question, looks like more of a comment. Renar has posted it, but I mean, I can get with you offline if you wish, Renar, so I can understand what your concern is.
Okay. So if there are no other questions, and then this is Ted Hoover. First of all, I'd like to thank everybody for joining these sessions, not this session, but for the entire year. I'm the program director on the Spectrum Scale product development team based in New York. I wanted to make you aware of a survey that we just posted online just in the last few days. Our development team is has developed this survey trying to get some insight from our users, from our user community on their use of cloud resources, workloads, and Spectrum Scale features that would be most important to them in running in a cloud. So any of the users that are currently running in a cloud or thinking about running in a cloud are welcome. Please take a look at this survey. I can't promise it'll be as interactive and fun as Simon's, but it is helpful for us to kind of get a little bit of insight on what's most important to our users so that it'll help us steer some of the development work that we're doing. So thank you. And I hope it's been up on the screen long enough that people can get the link. Can you get on the next slide? And again, thank you to everyone who joined. We would like to get some feedback on this talk and any other talks. There's an opportunity, to give that feedback. So as Simon had said earlier, we're always looking for some insights on what's most important in our planning of these user events, what's most important to the users, what type of talks, what type of subject matter experts would you like to hear from, over the course of the year. Hopefully our guesses will be true and we'll be able to talk to each other more face-to-face in the second half of next year. But then again, I think this has been a great forum for us too. So I want to thank everybody. And if you have any feedback to the organizers, please submit that. And I think that's our last slide.
Yep. Thanks, Ted. Yep. And thanks to all the speakers for speaking today and for all the speakers who've spoken to us, throughout the series we've been doing. We're taking a break in the talks over the Christmas and New Year period. We'll be posting dates for the next set of talks on the website probably early in the new year. So I'd like to thank Kedar and Ulf as well for their support with all these events, in addition to all of the speakers that we've had. I know they run around a lot with the IBM people trying to encourage speakers to come and talk. So thanks again, and with that, I think we'll close up.